For generations, astronomers believed the universe's earliest history would remain forever beyond direct observation. The first galaxies, the earliest massive star clusters, and the structures that shaped today's cosmos seemed hidden behind billions of years of expansion. Scientists could build mathematical models describing how the young universe evolved, but there was no way to witness those ancient epochs with enough detail to test every prediction. Everything changed with the launch of the James Webb Space Telescope. Designed with the largest infrared mirror ever placed in space, Webb was built to detect some of the faintest and most distant light ever observed. Because light requires time to travel, looking farther into space is also looking farther into the past. Every distant galaxy recorded by Webb is a snapshot of cosmic history, revealing the universe as it existed billions of years ago. Soon after beginning scientific operations, Webb surprised astronomers. Instead of finding a quiet young universe filled only with small developing galaxies, it detected surprisingly bright and well-developed systems that appeared to have formed much earlier than expected. These observations challenged several long-standing ideas about how quickly galaxies assembled after the Big Bang. Among Webb's most fascinating discoveries was a distant galaxy magnified by a phenomenon known as gravitational lensing. Informally called the spark galaxy, this incredibly distant object became one of the most important laboratories for studying the early universe. Around this stretched and distorted galaxy, Webb detected several tiny but extremely bright points of light. Detailed analysis suggested these objects were not ordinary star-forming regions. Instead, they appeared to be ancient globular clusters, dense collections containing hundreds of thousands, and sometimes even millions, of stars packed together by gravity. Globular clusters are among the oldest surviving structures in the universe. Unlike open star clusters that slowly drift apart over time, globular clusters remain gravitationally bound for billions of years. Because of their incredible age, they preserve valuable information about the conditions that existed when galaxies first began building their stellar populations. The light reaching Webb from these remarkable systems has traveled for nearly 9 billion years before arriving at the telescope's mirrors. That means astronomers are observing these clusters during a period when galaxies were still rapidly growing, merging, and evolving throughout the young universe. Although these are not the universe's very first stars, they likely represent some of the earliest massive stellar systems formed after previous generations of stars had already enriched space with heavier chemical elements. Rather than simply discovering distant points of light, Webb has uncovered preserved evidence from one of the universe's most important periods of evolution. Within our own Milky Way, astronomers have identified more than 150 globular clusters. Many are estimated to be over 12 billion years old, making them true cosmic fossils. Studying nearby examples has already revealed much about our galaxy's history, but observing similar clusters billions of light-years away allows scientists to witness them much closer to the time they actually formed. For decades, this was impossible. Even the most powerful telescopes struggled to distinguish these tiny objects at such enormous distances. Webb's extraordinary infrared sensitivity and exceptional image resolution have completely transformed that situation. By measuring their brightness, colors, and spectra, astronomers can estimate their ages, masses, and chemical compositions with greater precision than ever before. Each new observation brings researchers closer to understanding how the first generations of stars gathered into massive clusters, laying the foundations for galaxies that would continue evolving for billions of years. And these discoveries are only the beginning. One reason the spark galaxy became such an extraordinary scientific discovery is that Webb was not observing it alone. Nature itself provided an additional telescope. The discovery relied on one of the most remarkable predictions made by Albert Einstein's theory of general relativity, gravitational lensing. According to Einstein's equations, massive objects bend the fabric of spacetime. As light passes near an extremely massive galaxy cluster, its path curves, causing distant galaxies behind it to appear brighter, stretched, and magnified. In this case, a massive galaxy cluster located between Earth and the spark galaxy acted like a natural cosmic magnifying glass. Without this gravitational lens, even the incredible capabilities of the James Webb Space Telescope might not have been enough to resolve these tiny ancient star clusters. Instead, the combined power of Einstein's physics and Webb's advanced infrared instruments allowed astronomers to examine structures that existed when the universe was only a fraction of its current age. This achievement extends far beyond a single galaxy. For decades, astronomers have tried to understand how the first galaxies assembled so quickly after the cosmic dark ages. The newly observed globular clusters provide valuable evidence that massive star clusters may have formed much earlier and more efficiently than many theoretical models predicted. By analyzing the light from these clusters, scientists can determine their stellar populations and estimate how successive generations of stars enriched the universe with heavier elements. Those elements, including carbon, oxygen, silicon, magnesium, and iron, would eventually become the building blocks of rocky planets, planetary atmospheres, and the chemistry required for life itself. Every spectrum collected by Webb becomes another clue in reconstructing the universe's earliest history. Rather than relying entirely on computer simulations, astronomers are now directly observing objects that witnessed the formation of young galaxies billions of years ago. Perhaps Webb's greatest achievement is that it has transformed the distant universe from something largely theoretical into something directly observable. Photons that began their journey billions of years before Earth formed are finally reaching Webb's enormous mirror, carrying information from a universe that no longer exists in its original state. Each observation is effectively a message from the ancient cosmos. Yet Webb's journey is far from over. The telescope continues discovering increasingly distant galaxies that push the limits of what astronomers believed possible. Every new observation helps refine our understanding of galaxy formation, stellar evolution, dark matter, and the large-scale structure of the universe. Future observatories, including NASA's Nancy Grace Roman Space Telescope and next-generation ground-based observatories, will build upon Webb's discoveries, exploring even earlier periods of cosmic history with greater sensitivity and resolution. Together, these instruments will help answer some of astronomy's biggest questions. How did the first stars ignite? How did the earliest galaxies grow so rapidly? What processes transformed a universe filled mostly with hydrogen into one rich with planets, complex chemistry, and eventually life? The ancient globular clusters surrounding the spark galaxy remind us that the universe has preserved its own history inside traveling light. For billions of years, those faint signals crossed the expanding cosmos until humanity finally developed the technology capable of detecting and understanding them. James Webb has done far more than capture beautiful images. It has opened one of the clearest windows ever created into our cosmic origins. And somewhere beyond today's observational limits, countless more ancient galaxies, hidden star clusters, and forgotten chapters of cosmic history are still waiting to be discovered. With every new image, Webb carries humanity farther into the past, and closer to understanding how the universe became the extraordinary place we call home.